Hey, how are you guys doing? It's been a little bit since I had a chance to film. I wanted to get back to some of these questions from the end of the 2021 tests. I just didn't have time to film them in the past, and then I realized I had a problem request sheet that had a lot of problems on it to get to. So I filmed some of those. I'm going to get back to some of these now, maybe throw in some Amy questions, but it's almost too late for AIME prep. Congratulations again to everyone who did qualify for the AIME this year. Some of you have made comments down below that it looks like my lips aren't matching the sound, like the sound is slightly behind the video or something like that. I just wanted to acknowledge that that is an issue currently with my filming. Mainly it's because when I bought the laptop, I'd never owned one before. I didn't realize how much the video card and the sound card would impact capturing the video. And so what's going on is that my webcam can film at 60 frames per second, 1080p, but the video card can't quite process at that speed because it's the basic level video card. The reason is I had to borrow money to get the laptop, and I had a low budget. The laptop by itself was about $2,000, and I just couldn't afford to, splurge to make it $3,000 or something like that. And so this is what it is. I am going to try to upgrade the video card sometime in the next month or two, but I don't know when that's going to happen. And for the time being, it might look like my lips are dubbed, like it's a foreign film or something like that. Sorry guys, that's the breaks. You do what you can, Anyhow, 2021 AMC 10A problem 23. It was also the 12A, the exact same problem. We've got Frida the Frog. She's going to begin a sequence of hops on a 3x3 grid. So let's draw this 3x3 grid. It's essentially like tic-tac-toe, but maybe I'm going to put it in a box instead. And so she's going to start where? Moving one square on each hop and choosing at random the direction of each hop, down, left, or right. She does not hop diagonally, so never would go from center to corner. When the direction of a hop would take Frida off the grid, she wraps around, and she's got this teleportation ability. And if she was up here, for instance, she would jump up and end up down here if she was going to go off the edge of the board. Okay? So she would wrap around and jump to the opposite edge. It explains this too. For example, if Frida begins in the center square and makes 2 hops up, so from center up and then up again here, the first hop would place her in the top row, middle square, and the second hop would cause Frida to jump to the opposite edge, landing in the bottom row. This is what we talked about, right? Middle square. Suppose Frida starts from the center square, makes at most, this is important, at most 4 hops. Doesn't have to be 4 hops, okay? If you didn't read those 2 words, good chance there's a trap answer waiting for you. 4 hops at random and stops hopping if she lands on a corner square, the 4 corner squares. What is the probability that she reaches a corner square on one of the 4 hops? Okay, so basically, can she get from the center square, right? Can she get from there to the corner square in 1 hop? The answer is no, because she would have to go diagonal. So then we have essentially the probability that she lands there in 2 hops, plus the probability in 3 hops, plus the probability in 4 hops. And you will have to add those together as they are independent events. Okay, so how are we going to approach this exactly? We just came up with some kind of a plan, basically. I'm going to call the center square, instead of calling it X, I'm going to call it M for middle. I'm going to call this kind of square an edge square, and this will be a corner square. So how could she get to a corner square in 2 hops, right? Just kind of casework, if you will. And so she would have to go to an edge square. From the middle, she is 100% guaranteed to go to an edge square. So she would go from an edge to a corner is the only way to get there in 2 hops. Since she's guaranteed to be at one of the edge squares, we don't really care which one because they're all symmetric. In fact, she will then have 4 places she can go. She could go left, right, both of which are corner squares, back to the middle, or wrap around to the bottom. 2 of those 4 choices will take her to a corner square, so therefore this one is going to be 1/2, right? 1/2 chance of that happening. Okay, then what about 3 hops? How would she get there in 3 hops? Could she go from edge back to middle, back to edge? No, that's already going to be too many hops. She would have to take a 4th hop, which means that will be part of this one, but she cannot jump from the edge back to the middle if she's going to cover it in 3 hops. So that must mean that there's only one way to do it. It would be if she went edge, wrapped around to the bottom edge, and then got to her corner spot. Okay, how is that going to work? The edge is 100% guaranteed. You are guaranteed to land at the edge after her first hop. The next edge is not 100% guaranteed. Again, she could have gone down to middle to either of the corner squares or up to the edge square down below. It'd be up but wrap around, right? So the chance of her going to this bottom edge square is going to be a 1 in 4 chance. And now the corner square from there would be right or left. Again, it's the same as it was above. It's a 1 in 2 chance. Okay, this is going to give 1/8. Right now I want to explain one thing. You might be wondering, well, what if she went to a corner square and then here and then back to a corner square? Why aren't we counting that? Well, that's a good question. We should be asking those kinds of questions. The reason it says is that she reaches a corner square on 1 of the 4 hops. In fact, if she got to the corner square after the 2nd hop, we don't care what happens after. All of that's captured inside this 1 in 2 chance. Yeah, she's going to jump 2 more times, but we're not that interested in Frida's life. Frankly, once she's reached the corner square, we're kind of done with this frog. Okay? So, 1 and 2, and then probability 3 then is going to be this one. It's plus 1/8. Now, the probability of her getting there in 4 hops is going to be a little tricky. There might be more than one way, and I hope you're thinking about that. So what would it look like? If she's guaranteed to go to an edge square, then she had 2 outcomes for her second jump if it's not a corner square. One of them was the middle, and she could have gone back to the bottom edge, right? Now, that would be 1 jump, 2 jumps, then from the middle square, she's guaranteed to go back to an edge square, as we're calling them. The 4 like cross points that are not the middle one, right? And then from that edge square, she would have to go to a corner square. But if she was at this edge square, and again, we're trying to do it in 4 jumps, she's going to have to wrap back around, back to the top again to get E and then go to her corner square. This is it. You should be sensing right now that you're rounding third base and heading for home, right? So you're just about to get there. We just don't want to trip up, so do it carefully. Again, the edge square first jump is 100% guaranteed. We don't need to worry about it. It's 1 times. The middle square jump for this version here of the 4 hop arrival at a corner square is going to be a 1 in 4 chance that she goes back to the middle square. Again, she's right here. She could go left, right, up, wrap around, or middle. 1 in 4 chance she goes to middle. Once she's at the middle, 100% chance that she goes back to an edge square. And then from the edge square, there is a 1 in 2 chance that she goes to a corner. This is an additional 1/8. So the probability of 4 is actually 2 subcases. This one and this one. We will add 1/8 to that. Next up, EEEC. The chance of the edge again is 100% on the first jump. Another edge down below is the 1/4. So you're going to have 1/4 times. That's the chance she goes from the top back to the bottom. Same as it was before when we did it right here, right? Now she has to repeat that again. She has to go back to an edge square, which is wrap around back to the top. That's again going to be a 1/4 chance. And lastly, the 1 in 2 chance of the corner square. 16 times 2 is 32. This is 1 over 32. Convert all of your denominators to 32. You're going to get 16 plus 4 plus 4. These two are the same. Plus the 1 all over 32. 20, 24, 25, 25 over 32. These kinds of problems, again, you need to have a little bit of time when you get to them so you can think about it. This was not for an experienced problem solver who's completed Intro to Counting and Probability. I will link it in the description. If you don't own it, you should probably get it. This is some kind of stuff that you would do in there, right? It's just casework within a probability. Yes, it's 23, which means you might have limited time when you arrive here, unless you skipped where you should have skipped. Right, skipping things that you can tell you don't know. It's not up your alley. It's not one of your strengths. Skip those to get to questions like this. But again, the faster you can work through earlier problems, the more time you will have to spend on a problem 23. This would take, if you're not explaining it to someone, just to yourself, 4 minutes. 4 minutes, 3 minutes, 3 to 5 minutes or so. It kind of depends on how fast you read and process the information, but probably no more than 5 minutes if you have the experience of doing lots and lots of problems, specifically counting and probability. I hope this helps you guys. I will see you when I film next, and then I will see you guys in that video. Have a good one.